Okay, so here goes some practice with parabolas when they are shifted. You know the basics in terms of how they open and what the general form of the equation will look like. So here's an example. If the question tells us that the focus of the parabola is at 4, 2, and the directrix is the line x equals -1, what is the graph and what's the equation of the parabola? So strongly recommend. I've seen some students that try to do these in their head, and occasionally, rarely, it's successful. I recommend you draw it out. So a rough sketch, our focal point is over at 4, 2, and our directrix is the line x equals -1. So based on that, we know that the vertex is going to be directly in between them. So we have a total of, this is 4 and -1. I wanted even numbers just to start us off. So let's forget about the directrix being here. Let's say the directrix is at -2. Sorry about that. Okay, so what that means is that the distance in between the directrix and the focal point is 6, and half of that is 3. So our vertex is going to be right here, and we're going to have integer values for its coordinates, which makes it easier. So our vertex is at 1, 2. All right, we knew that because it was directly in between the directrix and the focus, and we know from that that P equals 3. Again, P, this variable, is the distance between the vertex and the focus, or the distance between the vertex and the directrix. We also know that the parabola is going to open to the right. So we can make a rough sketch. There's our parabola opening to the right. If we wanted a better graph, we would go 3 and then another 3 to get a point, and 3 and then another 3 to get our point for the focal width. But we're kind of focused on finding the equation. So based on the fact that it opens to the right, and based on the fact that P equals 3, and based on the fact that the vertex is no longer at the origin. So it goes like this. The fact that it opens to the right means that the general form of the equation would be an x equals, and it's going to be a positive 1 over 4p y squared. Okay, so that's using this piece of information. The parabola opens to the right. Then, based on the fact that p equals 3, we know that the equation would be x equals 1 over 4 times p and y squared. So this would give us y equals 1/12 y squared. So if the origin of this parabola, if the vertex of this parabola were at the origin, this would be the equation. We have to adjust our equation. So the fact that this was our first step, this was our second step, and then our third step, or third piece of information, is the fact that the vertex is now at 1, 2, meaning from 0, the vertex has been shifted right by 1 and up by 2. So the x-coordinate has been affected by being shifted to the right by 1. So it's going to look like this. X equals, and 1/12, that's a 1/12 right there. Do you believe me? And a y and parentheses squared. So this is where we're going to deal with how the x-coordinate has changed of the vertex, and here is how we're going to deal with how the y-coordinate has been changed. And like you learned in Algebra 2, when it's shifted to the right, we subtract. When it's shifted to the left, we add. And up and down is the same as long as we're dealing with right next to the y-coordinate. So it goes like this. Vertex was shifted to the right by 1, so we're going to subtract 1 from x. X, because that's side to side, and subtract 1 because it was moved to the right. Similarly, because the vertex was shifted up by 2, we're going to subtract 2 from the y. So because we're right next to the variable, this is why we're adding or subtracting, and it's reversed. And I like to think of, well, where is the 0? The vertex is where everything should be 0. And so if you plug in 1, you see how we have 0. And if you plug in 2, you see how we have 0. So if we plug in those coordinates, we get a 0 and a 0, and that's good because that's kind of what the vertex represents. So this would be the answer, and this is to help us with Khan Academy stuff. So our answer is like this, and if, and that's perfectly acceptable, and that's the way you'll see it in a lot of places. On Khan Academy, I'm trying to group these all together, so it will, okay, so we'll try that. Alright, so if you are, get that out of there. Alright, so if you're on Khan Academy, they may have x equals and then blank. Alright, and so based on what you have here, this is your equation, and you'd have to get x all by itself, so add the 1. So again, the way that I wrote that is good, but x equals, and you could have 1/12 and y minus 2 squared, and then plus 1, because the way that Khan Academy is forcing you to write the answer, we need the x all by itself, so that's why this is over here. Notice how, like, I see a common mistake where people will type in the x equals again, and then that messes them up. Alright, so let's go through one Khan Academy example, and you will be set. So the question is this, and they mess with you in that equation of parabola from focus and directrix. Sorry, you might need a calculator. So they say write an equation of a parabola with a focus here and a directrix here. So this is just like what we saw. Notice how it's y equals something. But when we go to graph it out, so our focus is at -8, -1. So 1, 2, 3, 3. Hey, this app is frustrating me. 4, 5, 6, 7, 8, -1. What is that? That's our focal point. And then our directrix, oh no, this is good. Write equation for a parabola with a focus at -8 and a directrix at y equals -4. Oh yeah, this is messed up. So 1, 2, 3, and 4. So our directrix then is down here. Alright, so based on that information, we know a couple things. One is that the vertex is directly in between these, and so you're counting the spaces, and there's 3 spaces, 3 units in between these. And so let's go, I'll draw this. Alright, so there's 3 in between them, and so we know that our vertex is right here. And you go, oh man, so the coordinates of the vertex are -8, comma, -2.5. I'll use decimals because that tends to be easier. Okay, so that's a little messy with the 2.5. And we also know that P equals, I think you can see the green, so that's 1.5, 1.5. We also know that P equals 1.5. Okay, so we draw it. We know that the coordinates of the vertex, because the vertex is here and our focus is here. We know the parabola is going to open upward. Okay, that's the information we need. So, like we did last time, I'll go through the steps where the first thing we used was the fact that the parabola is opening upward. So we know the general form of the equation is going to be y, and I'm going to write in those parentheses. Y equals positive 1/4p and x squared. Alright, that's because the parabola opens upward. And then we're going to plug in p. We know that p equals 1.5. And so this piece of information now tells us y equals 1/4 times 1.5 is 6 x squared. And then we're going to use the fact that the vertex is at -8, -2.5. So x has been moved to the left by 8, so we're going to add 8. And y has been moved down by 2.5, so we're going to add 2.5. So actually, I don't even have to rewrite it. Awesome. So x was shifted left by 8, so we say x plus 8. Notice how, if we plugged in -8, this would be 0. Our vertex is like the 0 the 0 point of the parabola, and y has been moved down by 2.5, so we say plus 2.5. And that is correct for the equation of the parabola. Notice how Khan Academy has this equals, and then you fill in the blank. So our plus 2.5, we're going to have to move over here by subtracting it from both sides. And our answer would be 1/6 an x plus 8 quantity squared minus 2.5. And that would be very nice. Okay. I think I wrote mine in fraction, and it was something like that. But that looks good. Thanks for listening.